Frame Relay. From Wikipedia, the free encyclopedia. Frame Relay is a standardized wide area network WAN technology that specifies the physical and data link layers of digital telecommunications channels using a packet switching methodology. Originally designed for transport across integrated service digital network (ISDN) infrastructure, it may be used today in the context of many other network interfaces. Network providers commonly implement frame relay for voice (VOFR) and data as an encapsulation technique used between local area networks (LANs) over WAN. Each end user gets a private line or leased line to a frame relay node. The frame relay network handles the transmission over frequently changing path, transparent to all end user extensively used WAN protocols. It is less expensive than leased lines, and that is one reason for its popularity. The extreme simplicity of configuring user equipment in the frame relay network offers another reason for frame relay's popularity. With the advent of the Ethernet over fiber optics, MPLS, VPN, and dedicated broadband services, such as cable modem and DSL, frame relay has become less popular in recent years. Technical description. The design of frame relay aimed to provide a telecommunication service for cost-efficient data transmission for intermittent traffic between local area networks and between endpoints in a wide area network, WAN. Frame relay puts data in a variable-sized unit called frames and leaves any necessary error detection, such as retransmission of data up to the endpoints. This speeds up overall data transmission. For most services, the network provides the permanent virtual circuit, PVC, which means that the customer sees a continuous, dedicated connection without having to pay for a full-time release line, while the service provider figures out the route each frame relay travels to its destination and can charge based on usage. An enterprise can select the level of service quality, prioritizing some frames and making others less important. Frame relay can run on fractional T1 or full T carrier system carriers. Outside the Americas, E1 or full E carrier. Frame relay complements and provides mid-range service between the basic rates ISDN, which offers bandwidth at 128 kilobits per second, and asynchronous transfer mode ATM, which operates in somewhat similar fashion to the frame relay but at speeds from 155,520 megabits per second to 622,080 megabits per second. Frame relay has its technical base in the older X.25 packet switching technology, designed for transmitting data on analog voice lines. Unlike X.25, whose designers expected analog signals with a relatively high chance of transmission errors, frame relay is a fast packet switching technology operating over links with a low chance of transmission error, usually practically lossless like PDH, which means that the protocol does not attempt to correct errors. When the frame relay network detects an error in a frame, it simply drops that frame. The endpoint have the responsibility for detecting and retransmitting dropped frames. However, digital networks offer an incidence of error extraordinarily small relative to that of an analog networks. Frame relay often serves to connect local area networks, LANs, with major backbones, as well as on public wide area networks, WANs, and also in private network environments with leased lines over T1 lines. It requires a dedicated connection during the transmission period. Frame relay does not provide an ideal path for voice and video transmission, or video transmission, both of which require a steady flow of transmissions. However, under certain circumstances, voice and video transmission do use frame relay. Frame relay originated as an extension of integrated services digital network (ISDN). Its design aimed to enable a packet switch network to transport over circuit switch technology. The technology has become a standalone and cost-effective means of creating a WAN. Frame relay switches create virtual circuits to connect remote LANs to a WAN. The frame relay network exists between a LAN border device, usually a router, and a carrier switch. The technology used by the carrier to transfer data between the switches is variable and may differ among carriers, meaning to function a practical frame relay implementation need not rely solely on its own transportation mechanism. The sophistication of the technology requires a thorough understanding of the terms used to describe how frame relay works. Without a firm understanding of frame relay